An artificial intelligence capable of monitoring our planet from space, interpreting images, and making strategic decisions according to them without any human interference. That's what China has just announced with a project to fully automate global satellite surveillance using artificial intelligence. Today, we are going to analyze the technical workings and the deep ethical debates behind this new space AI architecture. We will also see that China and the United States are making progress in turning lunar dust into building material, and they are planning entire cities on a permanent basis. They're on the moon, with a new generation of robots that are being trained to work where humans encounter their greatest limits. At the same time, giant rockets, while trying to pave the way to Mars, are still exploding here on Earth. And microrobots are being designed to access the human body and assist in medicine, so they can operate millions of kilometers from Earth, if that's possible. Let's understand all of this. Hello, impressed ladies and gentlemen. I'm Carlos Alves, and you're watching Incredible Reality. What would the world be like if satellites not only observed our planet, as they already do, but also interpreted what they were seeing, made decisions, and set priorities, without having to wait for our commands from human beings? Space surveillance has always worked like a gigantic network of eyes spread across Earth's orbit. But now China wants to turn these eyes into something much more sophisticated: an artificial brain in space. Chinese aerospace researchers recently unveiled the Air Target Agent System, a large architecture based on large language models. The same technological principles behind conversational artificial intelligences, like ChatGPT, for example, which we know today. The difference is that in this case, the AI is not answering questions. It is analyzing the images captured in space and coordinating complex real-time monitoring operations. The developers themselves describe the system as a combination of a central brain and an army of specialized tools. Instead of relying solely on conventional image recognition algorithms, the main model acts as an intelligent coordinator, distributing tasks to secondary agents who are able to analyze different types of data simultaneously. And this completely changes the speed of decision-making. Traditionally, satellite images had to go through several stages of intervention, before a conclusion could be reached. First, the capture, then the processing, and next, human analysis, and finally, decision-making. This new system aims to drastically shorten this process. Artificial intelligence interprets the context of the scene, identifies patterns, prioritizes information, and can even reorganize its own strategies when faced with unexpected situations. During the tests released by the researchers, the system demonstrated the ability to handle operational failures, as well as to reorganize tasks and continue carrying out its mission without direct human intervention. In practice, this means faster, more continuous, and potentially much more efficient surveillance. But this is exactly where a global discussion is emerging and intensifying. As artificial intelligence takes on these strategic functions, concerns are also growing about how much autonomy AI should have. In recent years, experts in defense, ethics, and technology have been warning that automated systems are no longer just simple support tools, but are becoming central elements in the decision-making chain. According to information associated with the Chinese Academy of Sciences, the next steps involve expanding the tests and validating the technology in much more complex and larger-scale scenarios. The goal is to further increase the operational capacity of the surveillance system, thus reducing the dependence on human operators. And this brings us to a question that goes far beyond technology, my friends. We are entering an era in which satellites not only observe our planet, but also begin to interpret events, set priorities, and act as extensions of artificial intelligences distributed throughout space. We know that these machines are already able to see us from Earth's orbit. But when it comes to power, we are willing to hand it over to systems that can learn to observe our world on their own. My friends, when artificial eyes up in space gain an artificial brain, surveillance stops being just observation and becomes understanding. This may be one of the most significant changes of the artificial intelligence era. So, in your opinion, do autonomous space surveillance systems make the world safer? Or do they make it more unpredictable and potentially also more dangerous? When it comes to governments, my friends, I'll let you decide. While you open up the comments section and leave your answer, let's take a look at what China and the United States are preparing on the moon. Let's check it out. How will the first human city be built on our natural satellite? Many of us are already imagining rockets transporting tons of steel, concrete, and equipment from Earth to create these permanent bases outside our planet. But there's a very simple problem, let's put it that way. Every kilogram sent into space costs a fortune. And the farther the mission is, the less viable this strategy becomes. That's why scientists around the world have been pursuing a fascinating idea. Building using the resources found wherever we go, on the moon, for example. And China has just taken a very important step in that direction. Researchers from the country have sent experimental samples of fibers produced from lunar soil into space. The goal is to test how this material behaves when exposed directly to the extreme conditions of the space environment, including radiation, brutal temperature variations, and the near-total vacuum. The manufacturing process starts with superheating lunar regolith, that layer of dust and fragments that covers the surface of the moon. When this material is heated until it completely melts, it turns into small liquid droplets. These droplets then go through a high-speed pulling and spinning process, which is similar to the principle used to make cotton candy. The difference is that instead of sugar, we're talking about melted lunar rocks. The result is ultra-fine, continuous, and extremely strong fibers with a thickness comparable to that of a human hair. The most impressive thing is that the first tests used only half a gram of real lunar material that was brought back from the Chang'e 5 missions. Even with such a small amount, the researchers managed to produce a continuous fiber about 3 meters long. And this opens up enormous possibilities. These fibers can be woven to form flexible structures, such as tents and habitable modules, or they can be incorporated into the so-called lunar concrete. In this scenario, they would function like the steel bars used here on Earth in construction. That way, they would reinforce walls, platforms, and future permanent installations. The choice of this approach is not random. Lunar soil has mineral characteristics that are similar to certain volcanic basalts found here on Earth, materials that are already known for their mechanical strength when transformed into fibers. In practice, we are beginning to learn how to turn lunar dust into infrastructure, and this could indeed be one of the most important changes for the future of space exploration. Because when a civilization learns to build using the resources of its own environment, it stops being just a visitor and starts wanting to become an inhabitant of that place. The big point is that these fibers represent much more than just a new building material. They symbolize humanity's transition from a species that only visits other worlds, or rather wants to visit, to a species that would be capable of living there. And the United States doesn't want to keep paying rent, so to speak, in Chinese facilities. Let's see what they're preparing for us there. NASA has revealed new details about a project that, if successful, could create the first human city outside of Earth. The focus is on the lunar pole, a region considered strategic because it has areas that are permanently illuminated by the sun and possibly water ice reserves hidden in shadowed craters. That's exactly where the U.S. Space Agency intends to establish a continuous presence in the coming decades. But surviving on the moon is far from simple. We're talking about an environment where temperatures can exceed 120 degrees Celsius under direct sunlight and drop to below minus 200 degrees in the permanently dark regions. There is no breathable atmosphere, no natural protection against cosmic radiation, and no easily accessible resources. That's why, before astronauts can settle for long periods, a huge infrastructure needs to be built. According to the plans released by NASA, the lunar settlement could gradually grow over the next few years, occupying an area comparable to that of a large city on Earth. The goal is not just to conduct scientific research. The moon will be used as a survival laboratory to prepare for the next major stage of space exploration, Mars. The moon would just be a station, a springboard to get there. However, before humans arrive en masse up north, on our natural satellite, we will send the machines. Starting in the coming years, robotic missions will begin transporting equipment, autonomous vehicles, scientific instruments, and life support systems to the surface of the moon. Private companies will play a fundamental role in this process. Blue Origin, founded by Jeff Bezos, for example, is developing landing modules that are capable of carrying heavy loads to the moon. Other companies, such as SpaceX, will also take part in transporting equipment, exploration vehicles, and infrastructure that will be necessary for future human operations. All of this is paving the way for the Artemis 3 mission, which is planned to take human astronauts back to the surface of the moon for the first time since 1972. But there is a huge difference between this new generation of missions and the old Apollo program. The astronauts won't just visit the moon, they will begin to occupy it. For the first time, our species is seriously beginning to consider expanding our presence to another world, to other frontiers. And if this plan works, future generations may look back at the decade of the 2030s as the moment when humanity stopped being an exclusively Earth-based civilization and officially became a multiplanetary species. But before colonizing the moon, we need to solve problems like the one we're about to see now. There are some serious things happening. The image that usually comes to mind when we talk about space exploration is always the same. A rocket cutting through the sky, engines roaring, and a gigantic machine leaving Earth behind. But the reality of the space race is quite different, my friends. Before every historic launch, there are thousands of silent tests. And sometimes, some of them end in a huge ball of fire. That's exactly what happened with the New Glenn, the next-generation rocket from Jeff Bezos' Blue Origin. During a ground test conducted in Florida, the gigantic spacecraft suffered a catastrophic failure that resulted in an impressive explosion that happened right on the launch pad. Obviously, no one was hurt in this case, but the incident drew a lot of attention from the entire space industry, because the New Glenn is not just another rocket. At almost 100 meters tall, it represents one of the main bets of the United States for transporting heavy cargo, satellites, and future missions related to humanity's return to the moon. The test that ended in an explosion was a relatively common procedure in aerospace development. Known as the static fire test, it keeps the rocket attached to the platform while the engines are fired to check the system's behavior under real operating conditions. In theory, this is exactly the moment when problems are supposed to show up. And they did, as you could see, right? Although the causes are still being investigated, the failure interrupted preparations for the next flights of the program and will force the engineers at Blue Origin to analyze a huge amount of data before authorizing new operations. What's interesting is that for those who work with rockets, accidents like this aren't seen just as defeats. They're also part of the learning process. SpaceX itself went through countless explosions before turning the Falcon 9 into one of the most reliable vehicles in history. The development of reusable rockets requires engineers to push gigantic machines to their limits, and this happens to discover failures that often only appear when everything is put to the test. And the New Glenn was created precisely to operate at that limit. Its goal is to compete directly with the largest launchers on the planet, carrying increasingly heavier payloads to Earth's orbit and, in the future, taking part in building the infrastructure that will be necessary for long-term lunar missions. That's why, despite the impressive images of this explosion, perhaps the most important aspect of this event isn't the fire, but rather the amount of information the engineers were able to collect. I've been talking for a while about sending humanoid robots into space, haven't I? This idea is now being taken seriously, or so it seems, leading us to the next topics in this episode. Let's go. Let's continue now. There is a very curious question that has accompanied robotics for a few decades now. If we are building machines for the future, why do they have to look like us? Why do we insist on making robots look like us human beings? The answer to this question started to become clearer during the Human Summit 2026, which was held in Tokyo. For 2 days, some of the most advanced companies on the planet presented their robots, which are capable of performing tasks that require a different level of precision. In addition, coordination and endurance that until recently were considered exclusive to us, human beings. Most interestingly, many of these projects are no longer developed just for use here on Earth. They are being created to work where we, human beings, find our greatest limits: space. And for all this to work, there is a fundamental skill that needs to be mastered first: the precise manipulation of objects. It was exactly at this point that Tokyo caught the world's attention. Among the most impressive demonstrations at the event was a new generation of robotic hands that are capable of performing extremely delicate movements. In one of the presentations, a robot managed to perform a task that requires fine coordination even for us humans: threading a needle. Even I have trouble doing that. In another demonstration, the robots handled tiny components with millimeter precision and did so without causing any damage to the parts. Yes, we've already gotten used to it, and it might seem like something simple when we see these robots doing it. But this kind of skill is exactly what's going to be necessary to assemble structures in space, perform repairs on satellites, or build future facilities using materials extracted directly from the surface where we'll be. The robots presented in Tokyo are not just learning to replace human tasks, they're being prepared to operate in places where we, human beings, have a lot of difficulty surviving. For us, it's almost impossible, right? From smart factories to future lunar cities, we're now witnessing the birth of machines designed not to copy the limits of the human body, but to surpass us. In the United States, they've also been working on this a lot, right? Coincidentally or not, it relates to the World Cup, which will also be hosted there. Let's check it out now. There's something curious about soccer. Our beloved soccer. At least for me, right? I mean, I play really well, you know? For humans, controlling a ball feels natural, but behind every pass, every change of direction, and every shot, there's an extremely complex sequence of calculations that the human brain performs without us even noticing. Balance, strength, coordination, movement prediction, and constant adaptation all happen in fractions of a second. And that's exactly why soccer has become one of the new training grounds for this physical intelligence in machines. In May 2026, Boston Dynamics presented new experiments involving Atlas, its most advanced humanoid robot. The goal wasn't to turn him into a professional player, at least not for now, but rather to teach something much more important: the ability to observe complex human movements and then reproduce them in adaptive ways here in the real world. At first glance, this might seem like just a technological curiosity, but what's being developed there, my friends, goes far beyond sports, you see? As we've already seen so far, in the coming years, private space agencies are planning to build the first permanent infrastructure beyond Earth. The moon has already stopped being just a destination for exploration and is becoming a possible construction site. And in this hostile environment, my friends, marked by reduced gravity, extreme temperatures, and constant radiation, most of the heavy work will need to be done by robots. The problem is that carrying materials, assembling structures, or operating equipment in such a different environment requires much more than strength. It requires adaptation. Simply shifting weight can determine whether a machine remains stable or loses its balance. An object that seems light to us can behave unpredictably when carried over uneven terrain. And it's exactly this kind of challenge that systems like Atlas are learning to solve. In the test presented by Boston Dynamics, the robot analyzed human movements and reproduced the complex patterns of body movement. The focus wasn't on the ball itself, but on how the body reacts to sudden changes in direction, weight distribution, and fine movement control. And the real story behind these advances, my friends, behind these tests, I believe is actually quite different. It's something else. Soccer is just a tool. The ultimate goal is much bigger. Because the same physical intelligence that lets you control a ball on the field could, in a few decades, right, help build structures on the surface of the moon, repair satellites in orbit, or construct humanity's first permanent bases outside of Earth. Why not? And if we humans are sent along with those machines, we'll need someone to take care of us. Or something to take care of us when an injury or illness occurs, right? Let's see how all of this is going to turn out. What happens if someone needs emergency surgery hundreds of millions of kilometers away from Earth and the nearest hospital? In May 2026, scientists from Nanyang Technological University introduced a surgical microrobot that's only 0.4 millimeters long. It's smaller than a common seed. Despite its tiny size, it is capable of performing multiple complex medical tasks, and it does so without any physical connection to the outside world. The importance of this technology becomes even greater when we look at the challenges of space medicine. In microgravity environments, bodily fluids don't behave the same way they do here on Earth. A conventional surgery could turn into an operational nightmare inside a spacecraft or a lunar base. Researchers are able to guide the device inside the human body with extreme precision, as if they were controlling a tiny microscopic submarine navigating through tissues and organs. In laboratory tests, the microrobot was able to cut tissues, collect biological samples, and generate therapeutic heat with high precision. Yes, my friends, for thousands of years, we humans have looked at the moon and the stars merely as static observers. Now we are slowly beginning, but we have already started to build tools to live among them. And maybe future generations of humans will remember this time as the moment when humanity decided to stop being just terrestrial and became interplanetary, just as Elon Musk and some others say. Who knows what the future holds? If you enjoyed this episode, remember to like and check your subscription. Sometimes the platform removes it. There are also 2 new suggestions on your screen. Just click on one of them and I'll see you in the next one. Thank you so much for sticking with me until now, okay? Just click, and I'll see you there. Thanks and bye-bye. See you soon. I'll see you there.